Now we are going to solve some problems which are based on these uh, different numbers, that is typical numbers, and some multiple and some multiple angles. So the first problem is, if cot theta is equal to minus 5 over 12 and theta lying between pi by 2 to pi, then find sin theta by 2 plus cos theta by 2. So the solution is, since cot theta is equal to minus 5 by 12, that implies tan theta is equal to minus 12 by 5. So with the help of this tan, we can find out secant square. Secant square theta is 1 plus tan square theta. Because with the help of secant square we find cos, and with the help of cos we can find sin theta by 2 and cos theta by 2 by using submultiple and multiple formula for trigonometric function. So just see, we will get 1 plus 144 over 25. That is, by taking the LCM we get 169 over 25. So as theta lies in second quadrant, secant is negative. So secant theta is equal to minus 13 over 5. That implies cos theta is equal to minus 5 over 13. So as formula known for submultiple, we know sin square theta by 2 is equal to 1 minus cos theta over 2. So we get 1 minus cos theta minus 5 over 13 over 2. So we get 18 over 13 into 2, that is 9 over 13. So as theta lies in second quadrant and second quadrant sign is positive, we get sin. So it is theta by 2, just as theta lying in second quadrant, that is theta is varying from pi by 2 to pi. Now what about theta by 2? It becomes pi by 4 less than theta by 2 less than pi by 2. That is in first quadrant. In first quadrant sign is positive and cos is also positive. So sin theta by 2 is as theta lying between second quadrant, that is pi by 2 to pi. What about theta by 2? It lying in first quadrant. In first quadrant sin and cos both are positive. Therefore sin theta by 2 is plus 3 over 13 under root 13. Now we have to find the value of cos square theta by 2. Cos square theta by 2 is 1 plus cos theta over 2. 1 minus 5 over 13 over 2. So we get 13 minus 5 is 8. 8 over 13 into 2. That is 4 over 13. So as cos theta by 2 is also positive in first quadrant, therefore cos theta by 2 is 2 over under root 13. Now we have to find the value of sin theta by 2 plus cos theta by 2, that is 3 over under root 13 plus 2 over under root 13. So that is, we get 5 over under root 13. That is our required answer for this problem. Now the next problem is sin alpha plus sin beta is equal to A and cos alpha plus cos beta is equal to B. Prove that first part, cos of alpha minus beta is equal to A square plus B square minus 2 over 2. So first of all we will do first part, then we will take the second part. So the solution is, as we have cos alpha plus cos beta is equal to B and sin alpha plus sin beta is equal to A. This is number 1, this is number 2. So on adding and, that is squaring and adding 1 and 2, because we have to get the value of cos alpha minus beta. Just see. We will get a square plus b square plus 2ab plus sin square alpha plus sin square beta plus 2 sin alpha sin beta, which is equal to a square plus b square. So we will get as cos square alpha plus sin square alpha is 1 and cos square beta and sin square beta is also 1, and we will remain with 2 is common. Cos alpha cos beta plus sin alpha sin beta, which is equal to a square plus b square. So we get 2 plus 2 times cos of alpha minus beta is equal to a square plus b square. That is, we get 2 cos alpha minus beta is equal to a square plus b square minus 2. So that is, we get cos alpha minus beta is equal to a square plus b square minus 2 over 2, and that is our required result. So now we are going to do second part of this problem. Now in the second part, prove that tan alpha minus beta over 2, that is submultiple angle of addition formula, that is plus minus under root 4 minus a square minus b square over a square plus b square. As we derive the formula of tan, sin and cos in terms of cos alpha. So using that formula in this case, because we know the value of cos alpha minus beta. So as we know that tan square alpha minus beta over 2 is equal to 1 minus cos alpha minus beta over 1 plus cos alpha plus beta. So we get 1 minus cos alpha minus beta is a square plus b square minus 2 over 2, and 1 plus cos alpha plus beta is 1 plus a square plus b square minus 2 over 2. So we will get, taking LCM, 2 minus a square minus b square plus 2 over 2 over 2 plus a square plus b square plus, that is minus 2 over 2. So we get 4 minus a square minus b square over a square plus b square. So we get tan alpha minus beta over 2 is equal to plus minus under root 4 minus a square minus b square over a square plus b square. That is our required result in the submultiple angle of alpha minus beta over 2. Now the next problem is, prove that sin raised to power 4 theta into cos raised to power 4 theta is equal to 1 over 128 3 minus 4 cos 4 theta plus cos 8 theta. So the solution is sin raised to power 4 theta into cos raised to power 4 theta is equal to sin theta into cos theta raised to power 4. So we have to change sin theta cos theta. So we get multiply by 2. Here 2 raised to power 4, that is 16. So we get 2 sin theta cos theta raised to power 4 to use product form in the form of sum and difference. So we get 2 sin theta cos theta is sin 2 theta, as we know that. So now we will use, and we have to convert all whole terms in the cos form. So we can write here sin squared 2 theta raised to power 2. And as we know that sin squared 2 theta can be written as 1 minus cos 4 theta over 2 in terms of cos. So we get 1 over 16 into 4 a square plus b square minus 2ab. So we get 1 over 64, that is 1 plus again cos square 4 theta. It can be written as 1 plus cos 8 theta over 2. This is the multiple of cos minus cos 4 theta. So we get here 1 over 128, 2 plus 1 plus cos 2 theta, 8 theta minus 4 cos 4 theta. So we get 1 over 128, 3 plus cos 8 theta minus 4 cos 4 theta, and which is our required result. So by using these multiple and submultiple formulas of trigonometric function, we get our required answer by using some trick, by keeping all the formula in mind. So if you fail to remind some formula, you can also derive this formula. You know the technique to derive the formula. So don't be confused. Just derive the formula in 1 minute and you can solve your question very easily.